So I'm going to have to do a re-recording of question 13 because I did a classic mistake. So for question 13 we need to find the maximum bending stress from our pen. Are you going to work for me? Yeah, there we go. From our bending moment graph, we've got the 1400 M value, so we can identify that. And we've used our chart value to use our table methods to find the second motive area, which is 45.4 times 10 to the power 6 millimeters to the power 4. And we were working in kilonewton meters. So now's the point to pause the video if you want to try and work out what the maximum bending stress is. So what's the maximum bending stress formula? So we're going to have bending stress is the bending moment times by the furthest distance divided by the second moment of area. What was my classic mistake? Well, I forgot about the kilonewton meters. So when we put our numbers into the formula, we want to remember and convert everything into SI units. So SI units in this case will be Newton meters. So 1400 times by 10 to the power 3. And then I need to look back at my previous result for what the furthest distance was. And what number was that? So that number was the distance going to the top, and that was 165.455. So that's in millimeters. So let's convert that into meters. Then finally the I value. So the I value is, at the moment, it's got times 10 to the power 6. Notice that it's millimeters to the power 4. So that means we need to divide it by 1,000 once, divided by 1,000 again, divided by 1,000 a third time, divided by 1,000 a fourth time. So your 10 to the power 6, which is why it's nice always to work in 10 to the power 6s, becomes 10 to the power minus 6. You know, we've knocked off 12 zeros there. So 45.4 times 10 to the power minus 6. So that's the number that needs to go into my calculator. So we've got 1400 times 10 to the 3 times by 165.455 times 10 to the minus 3 divided by 45.4 times 10 to the minus 6. And what do you think? Do you think all that weight's going to bend my my beam? Almost certainly. We got the stress here, so this is going to break for sure. So is 5.1 times 10 to the power 9, and I'll be working in, let's say, newtons per meter squared. So that's well beyond most stress limits for most metals, so I would imagine this thing will break. Okay, so watch out, make sure you convert all your units correctly into SI units. And stop my video.